Division. Before we get to dividing polynomials, let's just divide how we know how to divide already. Okay? So if I give you this problem, how do we start this problem? Do we say, how many times will 6 go into 3? We do that, but it won't, right? So what do? I scoot over a place. How many times will 6 go into 32? 5 times. Now, does it go into 32 5 times evenly? No. Where do I write the 5? Above the 2. So mostly I want you to know there's like a specific place for that 5, right? Now, there's not necessarily like the exact perfect place, and if you don't get it there, you're going to be wrong. But we just like to have a constant place that we write that, don't we? Okay? So what do we do with the 5 now? Multiply it by what? 6. What is 5 times 6? 30. Now, that's good. We meant it to be 30, right? Okay? Where do I write the 30? Under the 32. Now what? Subtract. Guys, is adding the opposite the same as subtracting? So if I just change the sign on the 30, it was 30, now I'm making it negative 30. Now can I just add? Yeah? What's 32 and negative 30? 2. 2. Now I'm done? Oh, bring down the 4. Bring down the next term. Okay, how many times does 6 go into 24? Ooh, 4. Now, I wrote it above the 4 because it's a 4 and it's the same number, so I write it above there? No, because it's the next place value over, right? Okay, so what do I do with the 4? I multiply times 6, so I get 24. Under the 24, and I either subtract or change the sign and add, right? Add the opposite. What do I get? 0. So if I said, what's the answer to this? You would say it is 54. What if I did all this work, blah, 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 and this answer was like 2? Like, I could add a 0, like a decimal place and a tenth and a hundredth and a thousandth to see how far I would go. But what if I said, we're not doing that. We're going to stay right here. What is this? It's my remainder, isn't it? Yeah, absolutely. It's my remainder. So how would I write the answer then? Well, I could write R2, right? But that's not the most mathematically correct. It's an easy way. It's a shortcut for when we're not really doing anything. But if I want to write the answer correctly, I'd write whatever the remainder is. I'd say plus, I don't want to confuse you, so I'm not going to write a 2. We're just going to use the 0, plus the 0 over, what was I originally dividing by? 6. Now, in this particular problem, that's not really adding anything because 0 over 6 is 0, right? But if I had a remainder like 2, and I had 2 over 6 or 2 over 7, whatever I was dividing by, that would be my remainder. You okay with that? Okay, then let's try this problem right here. 2x to the 4th plus 3x to the 3rd plus 5x minus 1 divided by x squared plus 3x plus 2. So most people's first reaction was, I can't do it, it's too hard. We're better than that, aren't we? We're smarter than that. We don't see this as a hard problem. We see it as a challenge. Dun, dun, dun. You ready? Okay, let's go on an adventure. Okay? How do we set it up? You think it might look like this problem? Yes. Yes, it will. So what goes on the outside? I'm going to need one of these thingers. Like a division bar, right? I need a division bar. What goes out here? Yeah, what I'm dividing by goes on the outside, doesn't it? X squared plus 3x plus 2. So what goes underneath the divisor bar? What you're dividing, right? This thing. Now, this problem is trying to be tricky, but you are smarter. What is the highest exponent in this problem? The 4. If what's underneath the divisor bar starts with a 4, every exponent below that needs to be represented. Okay, so if I have an x to the 4th, I need an x to the 3rd. Do I have a term that's x to the 3rd? Then it comes next. If I started with an x to the 4th and I have an x to the 3rd, what needs to come next? X squared. Uh-oh. I gotta have an x to the squared. X to the squared? Sorry. I have to have an x squared. Can I just put plus x squared? Oh, that changes the problem, doesn't it? Ooh, that's a good idea. What if I just added 0x squared? You okay with that? Does that change the value of the problem? No, I just added 0, right? I just chose to write it as 0x squared so that that squared is represented. What comes next after squared? Just x. Do we have a term that's x? So plus 5x. And what comes after x? The constant, right? Do I have... Oh, yeah, I do. Okay. Yeah, if I don't have a constant, I need to put a plus 0. Not 0x, but just a 0. Okay? Everything has to be represented. Yes, ma'am. Mm-hmm. If it's not... No, we don't have to do it in multiplying or anything like that. What if it was just x squared plus 2? Would I have to put one out here? No, that one's not necessary. Okay? This one's not... You can if you want. But what's necessary is if what I'm dividing into is missing a term. I've got to have my 0 in there. Okay? All right, so on this problem, we said we tried 3. That didn't work. So we went to the next one and said 32. How many times is 6 divided into 32? Well, this looks super messy, doesn't it? Okay, let me clean it up for you. Doesn't that look a lot easier? How many times does x squared, this term right here, go into 2x to the 4th? 2x squared. You okay with that? I'm saying what is the first term on the inside divided by the first term on the outside. Now, please understand that is not correct math vocabulary. You know that the right words, right? The divisor and all that kind of stuff. I'm not worried about correct math vocabulary. We got that. Or we'll get it soon. Fair? So I'm saying let's divide the first term on the inside by the first term on the outside. And I said, what is 2x to the 4th divided by x squared? And you said the answer was 2x squared. Where do you think I should write that? Does it make sense to put it above the x squared term? Yeah. Okay. Oh, wow. It's a good thing we put the x squared term in there. Then we wouldn't have anything to write it above. Okay. So plus 2x squared. I don't really need the plus. I don't know why I put it. I'm sorry. You can put it if you want. Now in this problem, once I put the 5 up here, what did I do? I multiplied whatever was up here by whatever's right here. In this case, I got 30, right? Well, what would I do here? 2x squared times x squared. What is 2x squared times x squared? 2x to the 4th. Would it make sense that I lined it up underneath the like term? Okay. What's 2x squared times 3x? Yes, 6x to the 3rd. That's exactly right. 6x to the 3rd. What's 2x times 2? Okay, thank you for answering the question I didn't ask. I didn't mean to say 2x. I meant to say 2x squared. Good job. Okay, 2x squared times 2 is 4x squared. Now what do? I either subtract or add the opposites, right? So I'm going to change the signs on every single one of these. I'm making each term opposite of what it was before because now I can just add. Does that make sense? Subtracting is what I'm supposed to do. I'm choosing to add the opposite because it's a little clearer what's going on. If I just put a subtraction sign out here, how many times do you think people forget to subtract this one and this one? Does that make sense? Okay, so 2x to the 4th minus 2x to the 4th. 0. Guys, if this is not 0 right here, you've done something wrong. We purposely divided this term by this term to get this term to go away. Yeah? Okay, so that's 0. What's 3x to the 3rd minus 6x to the 3rd? Negative 3x to the 3rd. Good. Huh. Now, I've never done a problem like this before. Well, I have, but you haven't, right? But would you know what to do next? You think you do? What do you think you would do? Oh, yeah, okay, so we just have to keep going, right? Okay, so 0x squared and negative 4x squared. So negative 4x squared. would it make sense that I would have to bring the rest of it down? Now, most of the time, you just need the next term, but you never know when that is for real, so I just always bring all the rest down. Yeah, that's exactly right. Now we start over again. Just look at the first term on the inside and the first term on the outside. What's negative 3x to the third divided by x squared? Now, can I show you something? I know some of you are saying the right answer, but can I show you something for the rest of you who are not? Sometimes I like to come over here to the side and say negative 3x to the third over x squared. Because that's really what I'm doing, right? I'm dividing. Can I simplify these exponents? Remember how the other day we talked about when we multiply like bases, what do we do with the exponents? We add. What about for dividing like bases? What do? We subtract. What is 3 minus 2? So that simplifies to x. So I have negative 3x. You okay with that? Let me show you one more way that's a little bit more visual. I don't want you to think this is some sort of weird trick, because you know how I feel about tricks. I don't mind shortcuts. Tricks confuse people. Okay? Negative 3x, x. Isn't that the same as x to the third? Over x squared. I'm allowed to simplify things that are like, if they're factors. So x over x is 1. X over x is 1. What's left here? A negative 3 and an x. Does that help you see and remember the rule about subtracting exponents? When we're dividing like bases, we subtract the exponents. Again, I don't want you to think it's a trick. I want you to know the math behind it. You okay with that? Okay, so now I know that my answer is negative 3x. So where should that go? Above the 5x. Negative 3x. Yes, ma'am? Yeah, if this was 3x to begin with, and I had negative 3x cubed and 3x, I would divide the 3's. Yeah, absolutely. Okay, so now that I have negative 3x up here, what do I do with it? Multiply. What's negative 3x times x squared? Negative 3x to the third. What's negative 3x times 3x? I think that's the question you were answering. Yeah. Negative 9x squared. What's negative 3x times 2? Negative 6x. And now, subtract or add the opposite. See how I'm not subtracting this time? Or, I mean, it doesn't look like I'm subtracting this time because they were already negative. If I'm subtracting the opposite of a negative, isn't that a positive? Yeah? So I have negative 3x to the third plus 3x to the third. 0. Negative 4x squared and 9x squared. 5x squared. 5x and 6x. 11x. Bring it down. Minus 1. And now, start all over. First term on the inside divided by the first term on the outside. What is 5x squared divided by x squared? It would be 5, right? Where does the 5 go? Over the 1, right? Plus 5. What's 5 times x squared? 5x squared. What's 5 times 3x? 15x. What's 5 times 2? 10. Now, add the opposite. 5x squared and negative 5x squared. 0. 11x and negative 15x. Negative 4x. Negative 1 and negative 10. That's all right. Wait, why would you think that was the remainder? Can you divide this term by this term? Can't, can you? This one is smaller than this one. Just like in that other problem we did. I don't know what I did with my paper. Oh, it's in here. It's in here somewhere. Yeah. I mean, it turned out to be a 0 this time, but like what if it was a 2? Could I divide 2 by 6? No, not without going to the decimal places, right? Okay. So this is my remainder. So what is my answer? So good. Don't whoa me as if I was a horse. Oh, okay. Oh, yes. Okay, whoa, math. You want to hear something even more yay? Let me ask you a question first, and then I'll tell you something even more yay. How did you feel about... Oh, sorry. How did you feel about this problem? Was it difficult? The steps, right? There's a lot of steps. Is it hard, though? Does it look hard? Yes, but was it hard once we got the steps down? Did you feel comfortable about this problem? There's no problems this hard on your homework. Yeah, there's no problems this hard. Okay, we're going. We're going there. Everybody have this one written down? Okay, let's go here then. What? I did not just spray something on my hand. My hands are right here. All right, can you set it up? What goes where? X squared plus 4x minus 2 is outside the box. What goes inside the box? Okay, first of all, I said a second ago we needed to work on math vocabulary because I was saying weird words, but I know that you knew what I was talking about because you use those words too. Okay, what is this term actually called? It's what we're dividing by. What is it called? Do you remember? It is the divisor. Okay, it's what we are dividing. Is that what you said? Good job. What is the term that we're about to put inside the box? Dividend. That's exactly right. It's the dividend. Okay, so if I start with x to the third, everything below it has to be represented, right? So if I start with x to the third, what has to be next? X squared, and we have one. So let's write it. 7x squared. What comes next? X. So I have one, so let's write it. And then minus 6. So I didn't have to add any zeros this time, did I? Everything was represented. That's good. See how that's a little easier than last time? Start here, just the first term of the dividend by the first term of the divisor. What do you get? X cubed divided by x squared? X, right? We're subtracting if we divide, so 3 minus 2 is 1. So we just have x. Where does it go? Above the 10x. What do I do with that? Oh, sorry. Because it's an x term, so I put it above the x term. It's not an x squared. I wouldn't put it up here. It's just an x term, so I put it above the x term. Excellent. X times x squared. X cubed. X times 4x. 4x squared. X times negative 2. Negative 2x. Now, please may I encourage you that if you are a visual learner, literally take a different color and change your signs. It really helps. Okay? It really helps to see that you have changed the sign. Okay? X cubed and negative x cubed. 0. Okay? 7x squared and negative 4x squared. 3x squared. 10x and 2x? 12x. And now I go on? Oh, yeah. I forgot to bring down the 6. I did. Whenever I change my sign, I do it to every single one. Otherwise, I change the value of the problem. Okay? Now what? Start all over. First term of the dividend by the first term of the divisor. 3x squared divided by x squared. 3. Where'd you get 7? Oh, okay. Now it's not this term. It's this term down here, like a new problem. We're starting like all over again. Okay? You okay with that? This first term right here by this first term right here. So that's a 3. Does that make sense? Okay, good. I'm glad you said that because we caught that early. 3x squared divided by 3, what? I got this from, yes. Well, they're not, wait, are you saying this x squared and this x squared? Yes, because remember 3x squared divided by x squared. Anything divided by itself is 1. This is dividing by itself, so I'm just left with a 3. Okay? Good. No, that's a good question. You guys know me by now. If it was a stupid question, I would tell you. 3 times x squared. 3x squared. 3 times 4x. 12x. 3 times negative negative 6. Ooh. When I change all the signs, look what happens. 0, 0, 0. What does that mean about this? That's my answer, first of all. Is that a special answer? Yes, it is. Okay? Now, I alluded earlier to the fact that we're getting to one of my other favorite things to teach. Okay? When you do long division like this and you get an answer of 0, that tells you that not only your answer and your not only your answer is, but so is your divisor. These are both factors of your original problem. It's one of my favorite things to teach is factoring. It's my second favorite F word. To fractions, what were you thinking? Rude. Well, they said they said earlier French fries, and I was like, oh my gosh, that is 2 F's. That's so much better. Are we okay with this one? Any questions about this one? All right, one more. That's even easier. Yeah, we have time. You ready? X minus 1 is my divisor. It goes on the outside. What's my dividend? 3x cubed plus 5x squared. (3x cubed, 5x squared, 0x minus 2. We had to add a term in there, didn't we? It was missing an x term. Divide the first term on the inside by the first term on the outside. First term of the dividend by first term of the divisor. It would be 3x squared. 3x squared. Now, there were some people earlier that were getting confused because they think it should have something to do with 5. But we're not looking at that when we're dividing, right? We're just looking at first terms. Okay? What's 3x squared times x? 3x cubed. What's 3x squared times negative 1? Negative 3x squared. And now, add our opposites. Or subtract, yes. This is 0. This is, try again, 8x squared plus 0x minus 2. Start all over again. 8x squared divided by x. 8x. 8x times x. 8x squared. 8x times negative 1. Negative 8x. Subtract or add the opposite. 8x squared minus 8x squared. 0. 0x and 8x. and then minus 2. Start all over again. 8x divided by x. 8 times x. 8 times negative 1. Add the opposite or subtract. 6. Start all over. Oh, no. Oh, we can't. That's my remainder. So that is my answer. Math! Woohoo! Questions?